How you doing, Professor? I just want to talk about question one, how I solved it. So as I'm looking at my answer, so first what I did, I calculated the sample proportion. 217 out of 649 women that experienced traumatic brain injury, and so I did P equals 217 over 649, and that equals 0.334 or 33.4%. Next, I had to check the conditions. So both NP and N, I put parentheses one minus P, close parentheses, and is greater than 10. So we could proceed. And then after that, the Z value for 98% confidence level is 2.33. I'm sorry, 2.33. So after that, I calculated the standard error using SE, which is square root. I put square root P parentheses 1 minus P, close parentheses over N, and which gives me the standard error of 0.019. And the confidence interval is P plus or minus Z times the standard error, or 0.334 plus or minus 2.33 times 0.019. And I got the results of 0.290 and 0.378. If you round it up, you know what I'm saying? So yeah, that's if you round it up. So that means we are 98% confident that our true proportion of incarcerated women that experience traumatic brain injuries and between 29% and 37.8% compared to the general population. The rate of 8%. The rate of 8%. I'm sorry, and this suggests that incarcerated women have significantly higher rate. So yeah. How you doing, Professor? I'm here to talk about question 2 of the exam. So so from the question you gave us, we were told what the 90 percentile score is, which is 278, and the mean is 238. So to find the 95th percentile score, we need to find the standard deviation, and we're not given that directly. So instead, we use the 90th percentile information to find it. So the Z-score for the 90th percentile is about 1.28. And so using the Z-score formula, Z equals X minus the mean divided by the deviation. You know what I'm saying, I plugged in 278 for the X, 238 for the mean, and 1.28 for the Z. So solving for the deviation, I put 278 minus 238 divided by 1.28, which gave me 31.25. And so next, we need to find the 95th percentile. So I used the Z-score for that, and it's about like 1.645, so 1.645. So I plug it back into the formula, X equal the mean plus Z times deviation. So that give me X equals 238 plus 1.645 times 31.25, and that equals 289.4. So for students that want to score in the 95th percentile, they have to score 289. So thank you. Yeah. How you doing, Professor? I'm here to talk about question 3 for the exam. So the first question, I said type 1 error, person is not guilty. So any person go to prison, this is a false conviction. So it was wrongly rejected, so not guilty. So that's what I got for the first question. The next question, type 2 error happens when it's failed to reject a false null hypothesis. So we assume a person is not guilty even though they are actually guilty. You know what I'm saying? So a guilty person goes free. They are not convicted when they should be. So yeah. So the type 2 error happens when like that. Um, and the last one, if we assume people are innocent until proven guilty, the legal system is trying to protect against the type 1 errors, wrongly, for, wrongly, wrongful, wrong. I'm sorry, wrongfully convicting innocent people. The innocent projects work with people who were wrongly convicted, meaning that the type 1 error it was committed against them. So they were innocent. The null was true, but was wrong. But the court was wrongly rejected, so they found them guilty. You know what I'm saying? So yeah. So type 1 error is false positive. That type 2 error letting a guilty person free, false negative. And then the innocent project case, the type 1 error, is protecting the type 1 error. The innocent people wrongly convicted, so they were found guilty. So yeah. The problem summary from the exam that I got, so the national average Pell Grant is 7,450. The university sample mean is 7,000. The sample size is 50. The sample standard deviation is 1,200, and the significant level is 0.05. And then I'm gonna use T for the distribution with like 3 degrees of freedom. So the first thing we have to state the hypothesis. So to state the hypothesis, we have to compare the university mean and the national average. So the null hypothesis is H0, I'm sorry, mean equals 7,450. The alternative hypothesis is H1, mean not equal to 7,450. So yeah. So next, B, we have to determine the test statistics. So I calculated this test statistics using this formula. T equals X minus mean 0 divided by S over the square root of N. And that will end up becoming 7,000 minus 7,450 over 1,200 divided by the square root of 50. So from that, what I got is negative 550 over 1,200 divided by 7.07. And that equals negative 450 divided by 169.71. And that equals negative 2.65. So the test statistics is around negative 2.65. So next we have to find the p-value. So I'm gonna use the distribution T with the 3 degrees of freedom to find the p-value. So the T statistic of negative 2.65 and the DF equals 3 and the 2 tails test, we doubled the area in 1 tail. So using the calculator, the 1 tail area is 0.0395 and the 2 tail p-value equals 0.079. So from there, I make the conclusion using the p-value. I compare the p-value 0.079 to the significant level 0.05. And since 0.79 is greater than 0.05, I failed to reject the null hypothesis. So in conclusion, it's not enough statistical evidence, to say that the mean Pell Grant at the university is different from the national average. So the final interpretation, like just to sum it all up, based on the test, the researchers does not have strong enough evidence to conclude that the average Pell Grant at her university is significantly different from the national average. But although the sample mean is lower, the variation in the award is high. It's too high, relevant to the sample size for this to be statistically significant. So for it to be that, it will be 5%. So 0.05, 5% level. All right, thank you. How you doing, Professor? I'm here to talk about question 5 for the exam. So first, we could be comparing the two ping pong ball manufacturing process to see if they produce the ball at the same average weight. So the first process produced with the average of weight of 2.67 grams, and the second process had an average of 2.642 grams. So we use the two sample t-test to compare the means of the two processes. So our null hypothesis is that both processes have the same mean weight. The alternative is the mean difference. The means are different, I meant to say. We concluded that the standard error to be around 0.055. The tested statistic is about 0.045. And the p-value for this test is like around 0.6. So since our significant level is usually high at 2.0, we're at 2, and the p-value is much less than that, we reject the null hypothesis. So to conclude, the two processes what's talking about, the two processes are producing balls with different average weights, and we made a type 1 error, which means that we thought there were a difference when there really isn't one. So yeah, so the conclusion is incorrect. Thank you. How you doing, Professor? I'm here to talk about the last question, number 6, for the exam. So we are testing the airline claims that their flights from Orlando to Miami takes around like 45 minutes on average. The sample of 90 flights found an average time of 45.96 minutes with the standard deviation of 4.13. I'm sorry. I want to see if this observed difference is statistically significant. So I calculate the standard error, which tells me how much variability I'd expect in the sample means. So that came out to be about 0.4352. And so after that, I used the t-distribution to the account for the uncertainty, and I used a t-value of 3.182, and for our confidence level. So using this, I built a 95% confidence interval around the sample mean. It ranges from 44.575 to 47.345 minutes. So then I asked, does the interview contains the value of 45, which is the airline's claim. So since 45 is not in the interval, we have evidence that the true mean of the flight time is statistically different from what the airline claims. So the 5% significant level, we reject the claim that the average flight time is 45 minutes. So thank you. Yeah.